All right, so let's keep going with these volumes. Um, but let's flip the setup a little bit. And so let's do volumes by slicing, but let's do them when they're rotated around the y-axis instead of the x-axis. Um, this is going to be sort of similar in setup to when you're doing areas between the curves, and you kind of change your perspective from an x and dx perspective to like a y and a dy perspective sometimes, right? Back in 6.2, to find those areas, you kind of need to sort of change your, change the way you're looking at it, change your perspective, and that can help with the setups. This is kind of an extension of that. In some sense, I would argue, maybe it's even a little bit easier to tell when you should and shouldn't use this in general, not all the time, but in general, if you're trying to do a volume with the slicing technique, using the pi r squared is kind of our kind of, the way we're thinking about this and the way we sort of get the slices and conceptualize the volume. If you're doing any kind of vertical rotation, right? So that is around the y-axis. You're going to want to set it up with respect to the y values, and where your functions are like x equals yada 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 in terms of y, rather than a y equals in terms of x. That we would kind of think of as standard. Again, all of this is arbitrary, right? But for the most part, the way we kind of write things, I think it's fair to say the x perspective is kind of the standard, and the y perspective is kind of the secondary. Anyway, let's look at a region bound by, so y equals root of x, x equals 0, and then y equals 2. And we're going to rotate it around the y-axis. So I've started to make a sketch here. I stopped just short of drawing in some of the discs themselves. We'll kind of go with this. So here's our root of x, right? It kind of goes and continues. Y equals 2 is horizontal line at y equals 2, so that's going to come across, it's going to run into each other, right? They'll sort of intersect here. That would be, right, x is 4 and y is 2. And then x equals 0 just sort of bounds us on the left, right? So the idea is we're taking that region and we're sort of rotating it around the y-axis instead. So rather than the rotisserie style rotation, this is like sort of stirring a pot of soup or something, right? You've got the wooden spoon in from the top, and then you're rotating it that way. Or you're like churning the butter. Boy, if if you thought my my other references were showing my age, wait till I talk about churning butter. I don't really know how to churn butter. I don't know. So you get some milk in a thing, and then you just stir it up real good. Well, I don't know. Anyway, it's a sort of a vertical rotation, so you're rotating around the y-axis. This gets us a little bit of a different picture. If I took this and I spun it around the x-axis, right, I would actually have kind of a gap between, and I'd need to sort of set it up with an outer and an inner radius. I'd have that kind of a setup like we did in the last video. This is going to get us a solid, right, and kind of the individual discs do something kind of like this, right? And our kind of radius values would be here. We would get maybe kind of one big one out like that. We're kind of getting our sort of funnel. It almost looks a little bit like a tornado, I guess, now that it's sort of vertical instead of on its side. We've kind of worked with shapes like this a couple times before. So what's the perspective here? In theory, right, our volume should be, right, kind of from A to B, this sort of pi r squared. In theory, dx. Now, what's going to happen here is we're going to do a change up. So we're going to change this to a dy, and I want my interval to be y integral. I want the interval to be y values. The idea here, right, is now my discs, right, the radius values on my discs are based on sort of y values as inputs, right? Everything is kind of flipped sideways now. So I'm running from 0 to 2 on the y-axis, and my radius values, my height values now are sort of going from 0 out to some sort of x equals value. The version of that I have is y equals root x. So I need to rewrite y equals root of x. If I change it, right, and sort of solve that for the x, that would be x equals y squared. In theory, right, that would also sort of get me the underneath part here, but because I'm only doing this from the perspective, right, from 0 to 2, I don't need to sort of put any kind of special extra information on here. So what's going to happen for our setup is this sort of y squared equals x, right? This is going to be my radius, right? Essentially becomes kind of my like height of the function. Again, my perspective here, if I'm trying to compare this to how we did the previous ones, essentially you're flipping it on its side, right? So now it's sort of, disc going this way in the same way that we were expecting. The rotation is happening like this. So my setup as an integral, right? So my volume is going to be, so from y equals 0 to y equals 2, right? From 0 to 2, pi times, right, radius squared, and then it's going to be dy. So that's from 0 to 2, pi times, so what's my function? So x equals, right, y squared, quantity squared, dy. I want to say we've literally done this area before, even though I don't have that right next to me at the moment. So simplify, right, y to the 4 dy. So this is just going to be, right, pi times 1/5 y to the 5 from 0 to 2. And if we sub these guys in, right, pi over 5 times 2 to the 5 minus pi over 5 times 0 to the 5. Perfection. What is this? 2 to the 5. I know we did that. 16. So that's 32 pi over 5 minus 0. Gets us 32 pi over 5. Perfect. I'm going to do another video here, and I'm going to maybe take a region and do setups where it's rotated from the x perspective and then rotated from the y perspective. So I'll do one setup rotated around the x and one setup rotated around the y. But that's in the next video, so you don't need to hear about that right now. The volume we're getting in this case is just 32 pi over 5.